Arcelor Mittal Dofasco is one of the most successful and advanced steel production facilities in North America. With a highly skilled workforce, industry-leading technology, and solid customer relationships, Arcelor Mittal Dofasco is an integral member of the Arcelor Mittal Group of companies. Our 800-acre, fully integrated facility is ideally situated along the St. Lawrence Seaway, which optimizes the intake of raw materials. Expert operators run a fleet of equipment that collects and distributes raw materials to our 3 coke ovens and 2 blast furnaces. Fueled by the quality coke produced at our coke ovens, our state-of-the-art blast furnaces turn iron ore into liquid iron, one of the main ingredients in steelmaking. The liquid iron is emptied from furnaces into torpedo cars, which move on a system of tracks to the steelmaking facility. Our steelmaking facility houses 2 steelmaking streams. Our fully integrated KOBM stream is based on basic oxygen furnace technology, and our EAF stream is a mini-mill using electric arc furnace technology. The hot iron from our blast furnaces comes into the KOBM facility, where each torpedo car is rotated to pour the iron into a ladle that will be taken to the KOBM vessel. 2 key materials are required to make steel in the KOBM: liquid iron and scrap steel. At a scrap handling yard just outside the KOBM facility, magnetic scrap cranes distribute the correct mixture of different grades of scrap into bins that move into the steelmaking facility on transfer cars. A crane then lifts the container up to the 325-ton KOBM vessel. After the scrap is loaded into the furnace, another crane pours in the molten iron. The furnace then returns to an upright position, and pure oxygen is injected from the top and bottom to melt and refine the mixture inside. After approximately 25 minutes, the operation is complete, and the liquid steel empties into a transfer ladle, which moves on to our ladle metallurgy facility. Here, steel samples are taken to determine if the properties are set to customer specifications. If necessary, alloys are added and mixed into the molten steel. Once the steel has been metallurgically refined, it is taken to our 2-strand caster, where the steel empties from a hole in the bottom of the ladle into the tun dish, which allows the molten steel to enter 2 continuous molds. As the steel travels through the molds, water cools the advancing strands so they can solidify. As the 2 strands progress and form slabs, they are then torch cut into various lengths, depending on customer specifications. On the other side of the steelmaking facility is our EAF stream. While our KOBM vessel combines 70% molten iron and 30% scrap, our 180-ton electric arc furnaces can be charged with 100% scrap, or 70% scrap and 30% molten iron. The contents are melted down by a combination of oxygen, natural gas, and electricity delivered through large carbon electrodes. Similar to our other steelmaking stream, the liquid steel is poured from the furnace into a transfer car, which automatically moves on to the EAF's own ladle metallurgy facility. After refinement, a crane lifts the transfer ladle up to our 1-strand caster, where the steel is formed into a continuous strand and then torch cut into slabs. Slabs produced at both steelmaking facilities are labeled and routed to storage areas until they are scheduled into the hot rolling operation sequence. When it comes time for a slab to be rolled at the hot mill, it is routed to the reheat furnace, which heats the slab to its optimum rolling temperature of approximately 1,200 degrees Celsius in about 2.5 hours. The heated slab travels to the roughing mill, where it is passed back and forth between rolls to reduce the thickness in increments until it is approximately 32 millimeters thick. As the strip enters the finishing mill, the lead end is cropped straight so that the strip will thread properly through the mill stands. The finishing mill reduces the thickness further according to the end-use requirements. Our finishing mill is made up of 7 stands, and each one contains 4 rolls that apply pressure to the strip. Computer systems precisely control the roll gaps and speed, as each strip requires different amounts of pressure and each mill stand turns faster than the one before. With the strip now at its required thickness, it passes through the strip cooling section, where 19 banks of water sprays cool the top and bottom of the strip. The strip then enters the down coiler, where the lead end of the strip catches and wraps around a rotating mandrel that forms the strip into a coil. It's now ready to be transported to the outside customers or to Dofasco's finishing operations. Hot coils are moved from the hot mill to an adjacent storage yard by 80-ton coil carriers and placed in the primary storage yard by 4 gantry cranes. Arcelor Mittal Dofasco's finishing operations include cold rolling, galvanizing, tin plating, and tube making. Coils bound for these operations are moved by 200-ton capacity coil transporters. Before steel can receive coating treatments like galvanizing or tin plating, the strip must go through the pickling process to be cleaned and the cold rolling process to reduce the strip's thickness. In each of our 2 coupled pickle line cold mill facilities, these processes are combined in one continuous operation. During the first stage, pickling, the coil is unwound and run through tanks filled with a hydrochloric acid solution, which removes the scale and oxides left during hot rolling or storage. The pickled strip then moves into cold rolling. Similar to the process at the hot mill, the strip passes through a series of mill stands containing rolls that apply tension and pressure to refine the strip. As the strip exits cold rolling, it is recoiled and labeled for routing to customers or other processes at Arcelor Mittal Dofasco, such as tin plating or galvanizing. Between our 5 galvanizing facilities, Arcelor Mittal Dofasco produces 6 different galvanized coated products. Before the strip can be coated, it must first be prepared in an annealing furnace which evenly heats the strip to create specific mechanical properties ideal for coating. After annealing, the strip passes through a zinc bath. Once the newly coated surface is dry, some galvanized products must go through a temper mill to reduce the strip thickness or to texture the strip surface for painting. Our galvanized products are shipped to customers in the automotive, construction, and appliance industries who require material that is strong and corrosion resistant. At our tin plating facilities, cold roll strip is pre-treated in annealing and tempering processes to ensure that it has the desired thickness and mechanical properties for the plating process. The strip then passes through tanks of tin solution charged with an electric current, which adheres the coating to the strip. The tin plate created at Dofasco is typically used for packaging products in the food and paint industries. All finished coils bound for external customers are sent to Dofasco's 10-acre central shipping warehouse. This 24-hour-a-day, 7-day-a-week facility handles 200 to 300 transport trucks per day, which ship finished coils to customers. Arcelor Mittal Dofasco also has 2 tube-making facilities at its Hamilton site. Tubes are made from hot-rolled strip that has been slit into lengths that are 20, 24, or 30 inches wide. The strip is fed into a welding section, where it is wrapped into a tube shape and then welded. A series of rolls further refines the tube's size and shape, and then the tube is cut into master lengths of 20 to 40 feet. These lengths are then cut down into shorter lengths so that they can be packaged and sent on to our tube warehouse. Arcelor Mittal Dofasco's success is based on the hundreds of experienced and knowledgeable people who guide all our operations. Working with health and safety as the top priority, they operate and maintain our facilities to ensure quality, efficient production. Their achievements prove what we have always said at Arcelor Mittal Dofasco. Our product is steel. Our strength is people.